good afternoon, gentlemen. Here today to listen to a presentation that I'm going to put together for you for anti-lock brakes and dynamic stability control. Okay, just before we start, let you know where the toilets are and the emergency assembly area at the front of the building. Okay, so just bear that in mind. If we do have an emergency, I'll go to class register and we'll all meet out in the assembly area. Okay, let's make a start. Okay, so today's presentation is an introduction to diagnose and repair vehicle dynamic control systems. Okay, there's some key points that we're going to look on. The presentation, anti-lock braking systems and DCS systems will be reviewed. These include traction control systems, electronic brake force distribution, and vehicle electronic stability programs. So our resources, what I've done is I've given you a handout of the PowerPoint presentation. If you look at your handout, there's an area down the left side. So as we go through each appropriate slide, you can take your own notes. I've also given you a handout of the acronyms list. So if we will be using acronyms throughout the presentation. So if you're not too sure on what they mean, you've got that list available to one side where you can check. Okay. All of the references and the material that's within this presentation has been taken from the Automotive Mechanics Volume 2, which you've all got a copy of. Okay, our learning outcomes. By the end of the lesson, you'll be able to explain the main ABS components, describe how anti-lock braking system functions, describe electronic brake force distribution, and describe traction control systems and explain electronically controlled stability programs. Okay, so why do we need ABS and dynamic stability control? Okay, if a vehicle's wheels lock during braking, the driver will lose control of the vehicle. ABS will prevent this from occurring. Steering direction control will be maintained. If we have a situation where we get a locked wheel, we'll actually lose steering control, so it doesn't matter which direction we turn the steering wheel, the vehicle will continue to travel straight. If we've got an intervention ABS, it'll keep the wheels rotating so we can maintain steering direction. It will also reduce stopping distance, okay? And a vehicle slide or skid can be prevented. We've got another thing that we use which is called brake force distribution. This is where the actual brake force to each individual wheel is controlled individually. Okay, so main components, what actually makes the ABS work. So some of the main components you've got there up on the slide, we've got our, look here, we've got our conventional brake booster, we've got our master cylinder, and then we've got our modulator. Okay, this is what is controlling our ABS functions. All right. There are a couple of other things up there. If we look over to the right hand side of the picture there, you've actually got an indication of a wheel speed sensor and the tone wheel. We'll move on to those a little bit further. Okay. So, hydraulic system. First and foremost, we've still got a conventional master cylinder and brake booster, and we apply pressure to the foot brake. Okay, and then the brakes because of that are actually applied. But we've got the situation where if we haven't got ABS, we're going to get the wheels to lock. So the modulator, which is hydraulically controlled, has 8 electrical solenoid valves built into it, and there's 2 for each circuit. Okay, so when the brake pressure from the master cylinder goes into the modulator, if we do get a wheel lock up, okay, a signal of a wheel lock up, the modulator is able to release the brake pressure to that individual wheel and prevent it from locking. Okay, so we've got to have control over each wheel, and that would be known as a 4-channel circuit. Okay, so we've got independent control over each wheel. Okay, the brake pressure is controlled by closing and opening the solenoid valves at appropriate times so that it provides maximum braking, but at the same time, actually stops the wheel from actually locking up. So what we want to do is we want to give maximum braking effect, and then at the point when the wheel locks up, we want to release that brake pressure so the wheel doesn't lock up. Okay, so this system, the modulator, is actually controlled electronically. Okay, so that we have to have inputs to the modulator for it to be able to process the information and actually do what it needs to do, and that's release or apply the brake pressure. Okay, so we've got hydraulic and electrical components, and they're controlled by an ECU. Okay, so there's an electronic component built into the modulator which processes information from the input sensors, the wheel speed sensors. Okay, with this arrangement, each brake can be controlled independently from the others. Systems can be designed either with 3 or 4 channels. If we had a vehicle with just 3 channels, we would find that the rear brakes are on 1 channel and both the front wheels are on independent separate channels. When we've got a setup like that, we can't control both of the rear wheels independently, only as one, okay? But most passenger cars have got a 4-channel system. Okay, so looking more at the electronic control, okay, the figure is a schematic of the system for one wheel. So if we look at the diagram there, look at the very top, we've got our control unit, we've got our ABS indicator lamp, and if you look down to the bottom, we've got our master cylinder, we've got our modulator, and we've got our brake caliper and brake disc, and wheel speed sensor there at the bottom left. Now this is only showing one wheel, but the cylinder is happening across all 4. So when we apply the pedal pressure to the master cylinder, the signal is sent to, the hydraulic pressure is increased in the modulator. And if we do get a lock-up signal, so if we lose the signal from the wheel speed sensor, okay, that is then transmitted as an input to the ECU. The ECU can then directly control the modulator and release the pressure to that brake and allow the wheel to start turning again. Okay. We've actually got a warning light on the dash as well. When the vehicle is first turned on, the ABS modulator will do a self-test on itself to make sure that there's no electrical problems with the system. Okay, the ABS electronic control unit, the ECU, which is usually located alongside the modulator, it's usually part of it, processes the electrical input signals to determine the acceleration and slip of the wheels. It then outputs commands to the modulator to release or apply the brakes. We've got a picture there, a little bit more detail of a wheel speed sensor. So we've actually got a reluctor or a tone wheel that is fastened to the hub. So it's rotating at the same speed as the wheel. We've got a sensor that's in close proximity to that reluctor or tone wheel. So if the wheel stops turning, we'll lose our speed signal, and then obviously the modulator and the ECU will release the brake so the wheel doesn't lock. Okay, so we've got there, the ECU then sends control signals to the hydraulic modulator, which influences brake pressure in the system. What we've got here is a schematic of the modulator showing all 4 brake discs there. Okay, and we've got the different channels, so we've got the 4 channels there, and we've got the solenoid valves which control the release or apply of pressure. Okay, integration of traction control and ABS. Now we've got a device that can actually control whether a wheel locks up. We can actually go a little bit further and incorporate a form of traction control to stop the wheels from actually spinning. So with this amount of control, we're able to have traction control option on the vehicle which stops the wheels from spinning in wet road conditions and when moving away. So for example, if we were moving away from the traffic lights and we've got a wet road, okay, we can prevent the wheels from spinning by applying the brakes. Okay. Something else we have to consider is electronic brake force distribution. Okay, ABS vehicles are provided with electronic brake force distribution. That means that the pressure between the front and the rear brake circuits can be controlled independently. We don't need no mechanical valves anymore. Okay, we can control that pressure. Okay, so by distributing the pressure between the front and rear brakes as required for maximum braking effect. EBD is an extension of the anti-lock braking system and is carried out by using the ABS components. So we're now actually using the modulator for EBD as well as traction control and as well as ABS. So it's a multifunctional device. With EBD, the brake system ECU is provided with extra programming to carry out brake force distribution. Okay, that moves us on now to electronic stability program. Okay, so This is a method of electronic intervention to prevent the loss of a vehicle. Again, this is another subsystem of ABS. Okay, so we've just progressed further by adding more software to the devices we've got on the vehicle. So we can now use a modulator to maintain or to avoid a possible loss of control of the vehicle by applying and releasing brakes on different axles. Okay, so it works using the vehicle's ABS components. So we haven't got no additional components, but we do need some additional programming of the ABS module. Okay, now we have to have some more inputs with using electronic stability programs, because we need to know what the yaw rate of the vehicle is. So we're getting an input now from a yaw rate sensor into the ABS modulator. So the modulator can compute the angle, the yaw, the roll of the vehicle. So this information, along with vehicle speed and steering input, can be used to control the vehicle and avoid a collision with no further input from the driver. So this is a safety system that can operate without any intervention of the driver. So the attitude of the vehicle will be monitored, and if intervention is needed to maintain control of the vehicle, it will automatically do so. Okay. It also incorporates a rollover mitigation within the program to prevent the vehicle from actually rolling over in a sideways drift. It will actually lock the wheels to allow the vehicle to slide rather than actually roll over. The only time that this wouldn't be particularly effective is if an obstacle was to come in the path of the vehicle and stop it completely. A roll could still occur. Okay, so we've got a few methods of testing ABS systems. Like I mentioned to you earlier, we do actually have a warning light on the dash, which will only prove out if a self-test is completed and also there's no faults detected. Okay, so the ECU of the ABS will perform an initial check when the vehicle is started. The ECU will then carry out a check when the vehicle reaches a speed of approximately 6 kilometers an hour. I know when this was first apparent on BF Falcon, a number of customers would complain that they heard a vibration type noise from under the bonnet when the vehicle started to move, and they came back complaining, but we reassured them it was just the ABS modulator performing a self-test on the solenoid valves. So it's purging the solenoid valves, and there's a little bit of noise that occurs when that happens, but again, nothing to worry about. Service points. If the ABS system does detect a malfunction, it will isolate the ABS system and prevent it from operating. So you will just have a conventional braking system at that point. It will then put on the indicator warning lamp on the instrument cluster to show you that you've got a problem. Okay, when the ECU receives signals from the wheel speed sensors, it checks the sensor operation. If an incorrect signal is received or there is no signal, then the ABS will also be isolated and a warning lamp switched on. So it's continuously monitoring itself for correct operation. Okay, so just to summarise, the ABS is an electronic system that prevents the vehicle's wheels from locking up. The traction control system is an electronic intervention that prevents the wheels from spinning when moving away. The EBD, electronic brake force distribution, controls the brake pressure between the front and the rear wheels. The ESP intervenes to keep the vehicle under control during a slide or skid. Okay. All right. Do we have any questions? Have you gone through your handbooks as I've actually delivered? So have you picked up, is there anything that you weren't too sure about that you'd like me to go over again? Okay, Hayden, what's the main principle or the main purpose that we have anti-lock brakes?
The main purpose.
Yeah, the main purpose. What's the reason why we've got anti-lock brakes?
So your brakes don't lock up when you're ready to go to brake very fast. You don't lock up, and then when you go to like almost reach that pressure where they could lock up, that it releases the pressure.
Okay, so if we're going to prevent the wheels from locking up, what advantages have we got in regards to safety because of that, in relation to steering perhaps?
You can still steer.
Okay, so the wheels are not going to lock up, so we're going to maintain control of the vehicle. We're still going to be able to steer, and that's going to allow us to avoid obstacles, isn't it? If somebody pulls out in front of us quickly, we can actually apply the brakes fully, and we can actually avoid the collision. Okay, so about traction control, what are some of the advantages of traction control? So remember how we talked about that in as much as it will actually stop the wheels from spinning. So when would that be an advantage? In the wet, exactly. Yeah. If we're trying to pull away, if the vehicle's on a bit of an angle, or if we're turning, yeah, we can actually stop the wheels from spinning. And how does it do that? How is it going to see that one wheel is spinning quicker than another? Exactly, the wheel speed sensors, because it's monitoring those sensors continuously. So if it sees one wheel speed up quicker than the other, it's going to realise that we've got a slip concern, and it will apply the brake to slow that wheel down. Okay, so the ABS is not only just releasing the brakes in a lock-up situation, it can also apply the brakes if we've got a slip condition. Okay, so with EBD, again, that is using another component, or the same component within the ABS, to do another job. So we're using the modulator to control the front to rear brake pressure, okay, to maintain that as it should be, because we know that if we had too much brake pressure on the rear of the vehicle, okay, that could affect the stability of the vehicle. Okay, and finally, ESP. When is the ESP going to intervene? Yeah, there is rollover mitigation for ESP, but also, for example, say we were travelling down the freeway and we needed to avoid a car that pulled in front of us in the lane, and we over-exaggerated our input to the steering wheel, and the vehicle started to go sideways. Before that would actually occur, information from the yaw rate sensor would have been passed to the ABS modulator ECU. It would have then formed a calculation and taken the appropriate action to bring the vehicle back under control. Okay. Any more questions? Okay, guys. Well, I've got a question paper I'd like you to have a look at for me. There's only a few questions on there, so I'll hand that out now. If you could, when you open it up, if you could, there's a spot in there for you to put your name and student ID. Mitch. You. So anybody, what I get you to do is just to close up your handouts. You can keep your acronym out and attempt those 5 questions for me. If you have any problem understanding any of the questions, then I can help you. As soon as you complete it, guys, you just fold your test paper up and leave it in front of you. I'll collect them. Just take a minute now, just to, if you've completed your test, just to have a quick look through your handout. If there's any questions on anything that you're not sure about, then we can, I can give a little bit of time before we do the survey to answer your questions. All done, Connor? Thank you. Scrap it all. You done, Cameron? Thank you. Thanks, Alan. As soon as you finish the test, if you've got your paper back, you can open up your workbook and just glance through it. Thanks, mate. I'm just handing out a survey now, which I'll give you an opportunity to fill out right at the very end. Just give some feedback, so it will help me improve any further training. So be honest with your answers. You don't have to put your name on the paper if you don't want to. Thank you. Next slide. Okay, gentlemen, thank you for your participation. There's a survey that I've handed out for you. If you could have a look at that. Is there any questions or anything that you weren't sure about? All okay? Okay, so the follow-on from this will be, this was really an introduction to dynamic stability control. As you know, we are going to progress further with this as the term goes on. So I'll let you know when those courses and classes are available. Okay, if you could just carry on do your survey for me now, and then we'll conclude. Like I say, be honest with it, but you don't have to put your name on if you don't want to. Okay, gentlemen. Final chance for any questions. You're all good. If you can leave your surveys on the table, I'll thank you for coming to the presentation today, and I hope you got something out of it. Thank you very much.